Hello, everyone. Welcome to this webcast. My name is Jeremy Eder, a principal software engineer with Red Hat. Today's topic is containers versus virtualization, the new Cold War. I'll be taking you through a brief technical overview of containers since they're so new, and I'll assume some basic knowledge of virtualization there. Take you through some misconceptions about containers, again, mostly since they're so new, some common misunderstandings about what the technology actually is and what it can offer. And then I'll take you through the meat of the presentation, which is workload classification. For the last decade or so, virtualization has been making its way into the data center. And at this point, many customers have reaching a majority of their workloads virtualized, mostly for cost savings. Virtualization requires that each independent application or group of applications be created on their own guest operating system. That means a dedicated kernel for that application or group of applications. It also means duplicated binaries and libraries, user space. This actually has a benefit of isolation and security because you don't share any of the environment with neighbors, either in a public cloud or a private cloud. Containerization, or sometimes referred to as kernel-level virtualization, or kernel-level multi-tenancy, relies on namespaces, a technology in the Linux kernel that virtualizes subsystems such as networking, process table, host names, things like that, to provide what looks like a dedicated environment from the application's perspective. Docker has popularized a container image format, although containerization has been around for actually several decades through different operating systems. The image format is due to the heavy lifting that Docker has done to standardize the industry on a common image format, and Red Hat has adopted that as ours for the time being. So that's the difference between virtualization and containers. And I'll dig into now quickly some of the common misunderstandings or misconceptions that I hear about containers, and I make some visits to customers and speak with them fairly often about this, generally from a performance perspective, because containers are supposed to deliver that type of benefit, and in fact they do. But there are still indeed some misconceptions out there. First of all, that they're new. I had mentioned previously they've been around for several decades. That is true through different operating systems. And in fact, most of the underpinnings that are used to deliver containers have been in the Linux kernel or Linux user space for several years. Red Hat's OpenShift version 1 and 2 used our own containerization technology that we built because there was no standardized offering in the ecosystem. So even Red Hat's been working with containers far longer than the most recent wave of popularity. Containers equal virtualization. In a lot of ways they do, in that, as I mentioned earlier, there's a virtualized, certain kernel subsystems are virtualized, such as networking and process table, and again, host name. But they don't actually equal virtualization in all ways. Again, shared kernel means that there are certain security, let's say, layers that are not possible with containers that are possible with virtualization. And Red Hat's using technologies like SELinux to enhance the kernel's namespace security already. Containers are universally portable. We'd like to think that Red Hat containers run best on Red Hat's operating system in a vertical integration stack type of a story. Part of the promise of a standardized image format is that they should be portable, and in fact they are to a great extent. There are certain things that prevent it from being 100% compatible between operating systems, between host operating systems and container images. And a lot of that happens in the interaction layers, more sophisticated interaction layers such as security and performance. They're secure by default. Containers are secure by default. That is in fact untrue. We have to do better at securing them, and actually there's plenty of work, particularly from Red Hat's perspective, in securing containers even further. I had mentioned SE Linux earlier, and tightening down certain facets of the kernel namespaces as well by implementing additional namespaces such as user namespaces. And that containers are not enterprise ready. Now the reality is Red Hat's been using containers for many years, even in Red Hat Enterprise Linux 6 with our previous versions of OpenShift, and they are indeed ready for the enterprise at this point. Another common misconception when comparing virtualization to containers is that they're so thin and so lightweight that you'll achieve massive density improvements, similar to how folks envisioned virtualization as improving their density versus bare metal. When there was a one-to-one relationship between applications and the bare metal, that was kind of the highest cost model, and virtualization helped us condense things to maybe a handful of VMs, up to maybe 20 is fairly common per per physical server. And there's been some rumors out there that the containers are so thin that you should be able to run, a little bit of hyperbole here, but maybe 10 billion containers for every VM. The reality is they are very thin, but this statistic is not what you should be paying attention to. And in fact, it tends to mislead folks. So I'll pose a question here. How many containers will you run on one operating system? A handful? A few dozen? Hundreds? We're hearing answers in the lower range here, dozens maybe, sometimes reaching 100. But that's fairly rare, and it depends on the use case. Workload classification. In this section, I'd like to define what a workload is and hone in on a model that allows you to choose what virtualization or containerization, what technology or applications should be deployed into, because it is all about the workloads. Some of these workloads don't care where they run. They might be end-of-day processing jobs for the finance department, or some may care very greatly where they run. Maybe they need to run on bare metal. Maybe they need the utmost in security. And maybe they need to perform. For example, most customers who host websites want their websites to perform as best as possible. So it is all about the workloads. But what is a workload? If you break it down, I have a food group analogy here that I use fairly often. In this case, drawing analogies between different food groups in security, stability, performance, and support. So if you break it down, how much security does your application need? And you can dial that up or down depending. How much stability does it need? Oftentimes, customers will require, for example, live migration technology so that they can do hardware maintenance, grouping that into the stability bucket there. Performance. Again, I mentioned there are some differences in performance between workloads that run on virtualization and ones that run on bare metal or containerized. So your application should have some performance requirements, and that is one of the decision factors in a workload. And then, of course, support. Some applications can be self-supported, and some you need vendor support for. In this grid here, I'm attempting to describe or create a heat map for the current state of affairs when it comes to particular types of workloads, whether it's CPU, memory disk, or intensive, or whether security is paramount, and again, live migration, or even running alternate operating systems other than Linux. The green dots indicate a capability where the three solutions are, for the most part, on par with each other. And yellow is where there are some potential caveats. For example, disk latency and virtualization we know falls behind bare metal due to the additional layers of abstraction that the hypervisor imposes. And there are plenty of ways to mitigate some of those overheads. But for the most part, out-of-the-box kind of thing, that's something to be aware of. If you notice, I've got a yellow dot in the container security section, and that's because I had mentioned earlier, if you've got a shared kernel, there's just simply no way it's going to be as secure as a dedicated kernel. While I don't have a slide on it, there's some upcoming technology that may allow a hybrid container and virtualization deployments. I'm going to be taking a look at those as well, several technologies that have been recently announced that allow you to use the container payload, the user space and application, and wrap them in a very thin VM. Those are things that are coming down the pike, and that will allow us to have container payloads running inside VMs. So we have the VM level security as well. The red dots, and there's only a few of them, indicate a capability that's not currently possible. And of course, bare metal live migration, that would be something that would have to be handled at the application layer for high availability, such as using a Red Hat cluster suite with virtual IP addresses. And also, I've got a red dot under the containers for live migration. It's not absolutely true because there is some work there going on called checkpoint restore in user space, or a similar technology that may be implemented allowing us to live migrate containers from host to host. Another interesting point about containers is that they've allowed an increasing or a decreased overhead to application deployment, and facilitating the DevOps movement, allowing developers to push code as quickly as possible and get it out into production. Bare metal, of course, has been weeks to months type of a range to provision and deploy. Containers can be in the hundreds of milliseconds if you've got the existing infrastructure. And KVM is only barely lagging behind that in the seconds to minutes range. Again, provided the infrastructure is already there. Customers that need to run alternative operating systems currently have a choice between bare metal or virtualization. Of course, we support different vendors' versions of Linux and Microsoft products inside our KVM virtualization solutions. Containers at the moment are only a Linux technology, and the reason it's yellow is because there will be potentially a way to run alternate operating systems in containers as time moves on. Again, a very fluid and fast-paced development environment with container technology right now. So if you take the previous slide, group your workloads and kind of take a fingerprint of what they actually need and want in the business requirements, and match them up against this type of a workload classification matrix. And you'd add your own lines, of course. These are generic. You can create a map and hopefully choose the best infrastructure to run your application. So the takeaways from this webinar: we can run containers inside virtualization as they would run in any public cloud environment. So the technologies are in fact complementary. They work well together and they're supported together. Containers augment your existing stack of software and infrastructure. They add additional capabilities. I had mentioned deployment speed as one of those. Ensure you can classify your workloads. Again, previous slide, your workload can tell you where it'll run best based on those characteristics and building a fingerprint. And finally, container technology from Red Hat is several years old. Several versions of OpenShift have come out and been supported. So it is truly enterprise ready. That concludes today's webinar, Containers versus Virtualization, the New Cold War. Again, my name is Jeremy Eder. Thanks for joining. You'll be receiving emails for future webinars. Thanks again, and have a great day.